Professor Bumbleweed here. Heat pumps sound like a scam, grabbing warmth from cold air and tossing it indoors. Yet physics stays stubbornly real. In a few minutes, these silent visuals show the whole trick. Moving heat around, not inventing it. No shouting today. The visuals do the heavy lifting. The ride stays half entertainment, half useful explanation. Where heat goes, how refrigerant changes state, and how one box heats or cools by flipping the flow. Time for a closer look. Heat moves from hot to cold, every time, like it follows the easiest route and calls it physics. Warm air warms a cold can, condensation forms where surfaces sit below dew point, and a sunny wall spreads heat sideways. Heat pumps exploit this rule instead of fighting it blindly. A refrigerator already moves heat the wrong way. It pulls heat from inside and dumps it into the room behind it. A heat pump copies that idea, just with the useful direction. Electricity runs the compressor, and heat gets shoved from outdoors into your living space. Reality stays rude like that. The machine looks like a metal box, but inside it is a relay race. Fans move air. Coils trade heat with that air. The compressor raises refrigerant pressure and temperature. The expansion device drops pressure again. Put together, those parts let one loop behave like a heater or an air conditioner. The refrigerant cycle is 4 moves. In the evaporator, low-pressure refrigerant absorbs heat and boils into vapor. The compressor squeezes that vapor, raising pressure and temperature. In the condenser, it releases heat and condenses. Then the expansion device drops pressure so it can absorb heat again. Simple loop, big payoff. In heating mode, the outdoor coil acts as the evaporator. It sits cold, so outdoor air gives up heat to the refrigerant, even when the day feels chilly. The compressor raises pressure and temperature. Indoors, the condenser releases that heat into air moving through the duct. The house warms, and the outdoors get slightly colder. Subtle, but true. Even stealing heat from cold air has limits. When the outdoor coil runs cold enough, moisture freezes onto it and blocks heat transfer. The system fixes that with defrost. Hot refrigerant melts the ice, water drains away, and normal heating returns. That little detour uses extra energy, so efficiency depends on conditions, not vibes. When the system cools, it drags heat out of the room and throws it outdoors. The indoor coil runs cold as the evaporator, so heat flows into it and moisture condenses on the fins and drains away. Outdoors, the condenser gets hot and dumps heat to outside air. Same cycle, different direction, same smug physics. Cooling is not only about temperature, it is also about water. When warm, humid air touches the cold indoor coil, moisture condenses and drains away, so the air feels less sticky. Airflow matters too. Return air passes the coil, then supply vents spread cooled, drier air. Comfort is basically heat transfer plus plumbing, glamorous. Efficiency looks suspicious because the heat pump is not converting electricity into heat the way a resistance heater does. It uses electricity to run a compressor. Then it transfers heat from outdoors to indoors, so the heat delivered can exceed the electricity used. That is the coefficient of performance concept. Congratulations, you found a loophole that physics openly allows. Heat pumps are great, not omnipotent. In very cold weather, grabbing heat from air becomes harder, so output and efficiency can drop and defrost happens more. The smartest upgrade often looks unexciting. Better insulation, fewer drafts, and proper system sizing. If the local ground stays warmer than winter air, a ground source heat pump taps that steadier reservoir. Nature provides options. Engineering picks the one that fits. Recap time. The static picture on that television shows the whole loop. Evaporator absorbs heat, compressor raises pressure and temperature, condenser releases heat, and the expansion device drops pressure, so it repeats. Heating and cooling are the same cycle with a direction swap. Heat gets moved, not created. Your skepticism takes a nap. If this felt interesting, tap the like button so the algorithm stops pretending it has no idea what people enjoy. Got a topic request? Drop it in the comments because silent visuals need a plan. Otherwise, I just gesture dramatically at a frozen heat pump picture. See you next time.